S3?
Yes, ma'am.
Okay. So, what was the structure of carbon I told you? What is this structure is called?
Tetra. Uh, what was it again? Tetrahydrovalent. No.
Tetrahedral.
Tetrahedral. Yes. Yes, ma'am.
Tetrahedral structure. So we know carbon can make four bonds, and these four bonds are oriented in a tetrahedral space. So do you know what is the name for this compound?
This is methane.
Methane. This is methane. So we have to
Yes,
draw
ma'am.
the structure of methane in tetrahedral way. What would we do? We will draw this carbon and then we will draw the four bonds in the tetrahedral structure. And we will place the four hydrogens at the end of these four bonds, right?
Yes,
And
ma'am.
one thing about this tetrahedral structure is the angle between these two bonds, like 1C8C bond, the angle between this is 109 degree 28 minutes. 109 degree 28 minutes. This is the point of tetrahedral bond. So if I go one further, now this one we call methane. Now what we will call it? C2H6, or if we write it down in an extended way, this is CH3, CH3. What do we call it?
This one is ethane.
This one is ethane. And what is the common thing we call of all of this? Like where carbon and carbon are singly bonded, what do we call it? Like what I'm asking is
Alkane.
alkane. So there can be three type of carbon-carbon bond. One is carbon-carbon single bond.
Yes, ma'am.
One is carbon-carbon double bond. This is carbon-carbon single bond. This is carbon-carbon double bond. And then we have carbon-carbon triple bond. So what we call what? The first one we call, as you said, alkane.
Alkane. The second one is alkene, and the third one is alkyne.
The second one is alkene, and the third one is alkyne. And now, if we go this way, the number of carbon. This is one chart. Okay, this is one chart we have to remember. And another chart we have to remember is so we add this suffix. We add in, we add in, we add ein. Now we have to learn it is number of carbon and corresponding suffix. So if we have 1, 2, 3, 4, 5, 6, 7. Let's do up. Up. If we have one carbon in our molecule, what do we call it? What is the, sorry, not the suffix, this is the
Yes, ma'am.
prefix.
Can you repeat?
Yes, I am asking that if we have one carbon in our molecule, what is the prefix that we will add?
It will be methane, right? And if it is single bond,
The prefix is
meth.
meth.
Yes, ma'am. Meth.
Meth. For two carbons, it will be
Eth.
H. For 3 carbons, it will be
Prop.
prop. Then 4 carbons,
But.
but. 5 carbons, pen.
Pen.
6 carbons, hex.
Hex.
7 carbons, hex. Then we have 8 carbons. 8 carbon is oct.
Oct.
Non.
Hmm.
And 10 carbons,
Deck.
pen. So you have written down these 2 charts.
Not yet, ma'am. I'll write down.
Write it down and let me know.
Yes, ma'am. Yes, ma'am. Done, ma'am.
Now if I ask you for some names, what we will call it?
Heptane.
15. How many carbons we have here?
7 carbons.
We will call it 15. Correct. Then what we will call it?
Propane.
Propane. First tell me, is this structure correct?
Yes, ma'am.
What I have written here in number 3, is the structure correct?
The last carbon, the hydrogens on the last carbon is incorrect. There are supposed to be 2 hydrogens on the last carbon.
Very good. There will be 2 hydrogens. So what we will call it?
Propene.
Propene. Okay. And if I ask you what will be the structure for propine, tell me what it will be.
For propine, it will be CH3 single bond, CH, no, C,
Hmm.
C, then triple bond, CH.
Very good. So this is the structure for propine.
Yes,
Now
ma'am.
coming back, what we will call it?
Heptene.
Heptene.
Heptene. Hmm.
Right. Now,
Yes, ma'am.
next. We have three. There is five, no? This is five. What we will call it?
This one would be this one would be heptene as well, or two heptene. No, heptene.
This one will be 15.
Heptene.
And similarly, this one will be
Hexene.
15.
Oh yeah, heptene, heptene. I miscounted it.
Then this one will be
This one, heptene again.
15 again, okay? I see. Finally, another one. Not another one, hopefully. Let's see. Is 2 CH2 CH2 CH double bond CH bond use 3. And what we will call it?
Heptene.
15. So all of these are 15. All these are same compounds, you are telling me. But I can see these are not same compounds.
No, we are supposed to add the numbers where the double bond is, but I did not
Yeah,
choose
so
the
tell
number.
me with the
Hmm.
numbers. So what will be the first
Yes,
one?
ma'am. For the fifth one, it would
For
be
the first one. Yeah, fifth one, right. Yeah. Fifth
hmm,
one means
4 heptene.
4 15.
Hmm.
Where do we start counting?
From the left side, because it would be the least amount, like
So if
it's the
we
least
start
number.
counting
That's
from
why.
the left side, this is 4 15. Between which carbon the double bond is there? It is third carbon and the fourth carbon, na?
Hmm.
So which number we take? We take the number 3.
Ah, yes, ma'am. 3. No, I took it as from the backward, it would be more. So I took it from the left side.
This is 3 15.
Hmm.
The next one will be
2 heptene.
2 15. The seventh one
It would be heptene because it's of the first carbon
would be
itself.
1 15. You have to mention the number. Even if it's in the first carbon, you have to mention the number, okay?
Hmm. Yes, ma'am.
So this is 1 heptene. Then the eighth one is
One. From the right side, it would be 3 heptene.
very good. So for the seventh one or the eighth one, oh yeah, for the eighth one, you have to start counting from the right side because
Yes,
from the right side, it's coming in the lesser number.
yes, ma'am.
Okay. So this is again 3 heptene and the ninth one will be
From the right side, 2 heptene.
hmm, 2 heptene. So we have to count it from the side, from which side it is coming to a lesser number, right?
Yes, ma'am.
So these two are basically same compound. Clearly these are same. One we are seeing from this side, another we are seeing from this side. And
Hmm.
these two are same compound. Similarly, if we have added a double bond here, then it would have been same as this compound, right?
Yes, ma'am.
Okay. But coming back to propene, you see, the problem didn't happen for propene. Why? Because the other thing we could draw is CH2, CH, CH3, which is basically the same,
Hmm.
right? So for
Yes, ma'am.
propane, this is not a problem. So up to propane, it's fine if we don't mention the number. When it comes to bond, double bonds, when it comes to substituent, in that case also we have to add the number in propene. But when it comes to bond, we don't have to add a number in propene. But propene onwards, like butene, heptene, pentene, in all the
Hmm.
cases, we have to mention the number. Fine?
Yes, ma'am.
Okay. Now coming to substituents, this is called methane. So this is a substituent, like this carbon, like methane is what? Now I am drawing it in the normal way. Now if we break this bond and remove this hydrogen, what will happen? Then carbon will be able to make one more bond, right?
Hmm. Yes, ma'am.
So this is CH3 bond. This is this structure.
Hmm.
CH3 with a extra bond. So what we call it?
Um, CH3 with an extra bond. Halogen. Like we add a halogen like
Mhm.
chlorine, bromine, iodine.
We call it methyl. This is methyl group.
Hmm.
Yeah, that's a different part. I am asking that what this quantity or this substance is called. This is called methyl. So when we remove one hydrogen from the methane, we call it methyl. Okay.
Ah, yes, ma'am.
Then
Yes, ma'am.
then this is C2H6. This is ethane.
Hmm.
Ethane, or we can write it as CH3 CH3. This is ethane.
Yes, ma'am.
Now, if we remove one hydrogen from here, that is, if we make it C2H5, or if I write it in an expanded manner, this is CH3,
CH2. So it will be
CH2.
ethylene.
It will be ethyl.
Hmm.
Similarly, it can be propyl, butyl, right?
Yes, ma'am. Yes, ma'am.
So, if we now draw this, ask you about this compound. Is this correct?
No, the middle carbon should not have two hydrogen bonds. It should have only one hydrogen bond.
One hydrogen, right? Okay. So, what we will call it?
2-methyl propane.
Ethyl propane. Very good. Methyl propane. And as we know that we won't give any space between methyl and propane. That is the rule of writing IUPAC nomenclature. You have heard this term, right? IUPAC nomenclature.
Yes, ma'am.
This is what we are doing.
Hmm.
IUPAC nomenclature. and there will be a hyphen between a number and a letter, right?
Yes, ma'am.
And
Yes, ma'am.
if we come across two consecutive numbers, then we have to put a comma between two numbers. Okay, this is the rule. Okay, so this is 2-methyl propane.
Yes, ma'am.
Then what we will name it?
Yes, ma'am.
CH3, CH, CH2, CH3. What we will name it?
Yes, I can see now. I can see now.
Okay. So what we name it? The second one.
This one would be 2-methyl butane.
2-methyl butane. Very good. Okay. Next. What we will call it?
This will be 2-ethyl propane.
Would you like to recheck this one? Would it be 2-ethyl propane?
Or maybe no. This one will be 2-methyl butane because CH3 CH C2H5 is a longer chain than CH3 CH CH3.
So it won't be 2-ethyl propane. It will be 2-methyl
2-methyl
butane.
butane.
Right. So it won't be this one. Good that you corrected. Okay. Now, coming back to something different, then tell me what were the things you have learned already?
11 till now.
Till now, what we have you have learned in chemistry. It doesn't matter which class, whatever you have learned. Tell me.
Uh, yeah, organic chemistry, types of reactions, and
Mhm.
uh,
So what are the types of reaction?
combination reaction, decomposition reaction, displacement reaction, redox reactions, oxidation, reduction reactions, double displacement reactions based on reactivity.
You have learned all this already.
Yes, ma'am. This was done
These
in
were
10th.
these were in your class 10 syllabus.
Yes, ma'am.
Okay. Okay. So can you give me an example of displacement and double displacement reaction?
Displacement. Uh,
One is
uh,
displacement. Okay. Tell me the names you have told me. Displacement. Then you told me double displacement.
displacement, double displacement, combination reaction,
Okay.
decomposition reaction,
Combination reaction. And you told me decomposition reaction. So can you give me an example of each?
each. I'll have to think a lot because I don't quite remember
Take
the
time. Take
examples, but
some
I
time.
remember what they are.
Take some time and tell me. Try to think of something and tell me. No hurry.
Yes, ma'am. For displacement reaction, for example, uh, when we take brine solution NaCl plus H2O and we pass electricity through it, we get NaOH, sodium hydroxide, and chlorine and hydrogen as byproduct. So Cl is replaced, chlorine is replaced by a hydroxide.
And as byproduct, what we get? We get HCl or H2 and Cl2.
We get Cl2 and H2 individually.
We get Cl2 and H2. Okay. And an easier thing for this is, okay, I'm coming to that. Next, double displacement reaction.
Double displacement reaction. Uh, Double displacement reaction. NaCl plus BaSO4 gives NaSO4 plus BaCl.
Please say it again. NaSO4.
Uh, oh, wait 1 second. NaCl
Yeah.
plus BaSO4 gives NaSO4 plus BaCl.
What is the valency of sulfate?
Valency of sulfate? I don't remember.
What is the
I think
formula for sulfuric acid?
for sulfuric acid, H2SO4.
H2SO4. What is the valency for hydrogen?
Valency 1.
Then what will be the valency for sulfate?
Uh,
See, in H2SO4, you have told me the formula for sulfuric acid is H2SO4, right?
yes, ma'am.
So, if the formula for sulfuric acid is H2SO4, now you have told me that the valency of hydrogen is 1, and now sulfate
Hmm.
is needing 2 hydrogen to fulfill its valency, then what will be the valency of it?
2.
2.
Hmm.
So, the valency of sulfate will be 2. Now, what
Yes,
is the
ma'am.
valency of chlorine?
Valency of chlorine would be 7. No, not 7. No, not 7. Sorry. 3.
Hmm? No, 3, not 3. 7 was the
No?
answer for. No, the 7 was the number for valence electron. Number of valence electron in chlorine is 7.
No,
But
for
if the
valency is like less than 4. Not,
valence is
it
less than 4,
doesn't
yes. So if
4.
the
Hmm.
atom has 7 electrons in the outermost shell, how many electrons it is needed to make it 8?
4 more.
It has 7 electrons already and it needs 4 electrons
Ah,
to
yeah.
make it 8.
No, no. It needs one more to make it 8.
It needs one more electron to make it 8.
Hmm. Hmm.
And 1, it is 8, it is stable. So it needs 1 electron. So the valence for chlorine is
1.
1. And if you are confused, you know the valency of hydrogen. Valency of hydrogen is 1. And what is the formula for
Yeah, sure.
hydrochloric acid?
For hydrochloric acid,
Hmm?
HCl.
HCl. So it takes only 1 hydrogen to fulfill the valency of chlorine. Then the valency of
Hmm.
hydrogen is 1. Then the valency of chlorine will also be 1.
No, I for valency I subtracted the wrong number. I subtracted
Okay.
7 with 4 when I was supposed to subtract with 8. 8 minus 7.
Yes. Yes. So valency of chlorine is 1. Then what will be the valency of sodium? Look at here. What will be the valency of sodium?
For sodium, it would be
How many
2
sodium
because
is, no, look at here. What, look at NaCl. What is the, how many sodium is needed to fulfill the valency of chlorine?
1, but it could be Na2Cl2 as well. So that's why the 2 are not written.
It can be Na2Cl2, but in that case, we have 2 chlorine already, na? 2 chlorine, 2
Hmm.
sodium. That means 1 sodium for 1 chlorine. So
Hmm.
the valency for sodium is
1.
1. And you told me what is the valency for sulfate?
1.
Sulfate was 1. You have just told me here.
Oh, no, sorry, 2.
2. So the valency of sodium is 1 and valency for sulfate is 2. So we have this compound NaSO4. You have told me the formula NaSO4. Is that a correct formula?
No, it is, I think, Na2SO4.
It would be Na2SO4. Correct.
Hmm.
And what this will be?
This will be BaCl2. Two, I think. BACL.
BaCl2.
Hmm.
Exactly. Why?
Hmm.
Because we are needing one barium for one sulfate. So sulfate
Yes,
has
ma'am.
two. Sulfate
Yes,
has
ma'am.
two valency. So barium has to have
Hmm.
two valency too. And we have
Yes,
seen
ma'am.
that chlorine has one valency. So we will need two chlorine to fulfill the valency of barium. Okay.
Yes, ma'am. Yes, ma'am.
Now, if this is our reaction that NaCl plus BaSO4 gives us Na2SO4 plus BaCl2. Now tell me how many sodium chloride we will be needing. The reaction is not balanced.
Two sodium chloride.
Two sodium chloride. See, if we write it 2 here, 2 NaCl plus BaSO4, that gives us Na2SO4 plus BaCl2. So
Hmm.
you see here we have 2 sodium, here we have 2 chloride, 2 sodium, 2 chloride, 1 barium,
Yes.
1 barium, 1 sulfate, 1 sulfate. So the reaction is balanced. So this is a double displacement reaction. Correct. Now give me an example for combination reaction.
Um, H2 plus O will give H2O water. Simple reaction.
2H2.
Hmm. 2H2
2H2
plus
plus O2 will give us
O2 gives 2H2.
H2O. We can't write it as H2 plus O gives us H2O because in nature we can't get oxygen in this form. In nature we get oxygen
Yeah,
in
yes,
this
ma'am.
form. Okay. So this
Hmm.
is
Hmm.
not
Yes.
correct. Okay. So this is combination reaction and what will be decomposition reaction?
Decomposition reaction, electrolytic reaction, where we are separating the atoms from the water molecule. 2H2O,
Decomposition,
we pass the
right?
electricity through it.
Hmm.
So hydrogen comes out from the cathode and oxygen comes out from the anode.
Very good. The decomposition is somewhere a compound is getting decomposed or broken.
Hmm.
So a very easy
Hmm.
example for this, very easy and very important. That is calcium carbonate. It will give us calcium oxide and carbon dioxide. Okay.
Yes, ma'am.
So here, write this down. These are very important. Actually, write. You have written all this down, right?
Ah, yes, ma'am.
Okay. So this is a very important reaction. Calcium carbonate breaks down into calcium oxide plus carbon dioxide. Okay.
Yes, ma'am.
Okay. Now let's do one thing. Solid, liquid, and gas. These are the three states of matter, right?
Yes, ma'am.
Matter can have only these three states. It can have plasma, but that's not we are going to consider. So it can have solid, liquid, and gas. So now what we are trying to do, we are trying to differentiate solid, liquid, and gas. What is the difference between solid, liquid, and gas?
In solid, the atoms are closely packed together. They have more intermolecular force and less intermolecular space between them. It has a
Okay,
definite
okay,
shape,
okay,
definite volume,
okay.
definite mass.
Mm-hmm.
Um, it has its own shape.
Yeah, you have said everything about solid. Now let's come to liquid. Define liquid.
For liquid, it has less intermolecular force than solid, but more intermolecular force than gas. And it
Space.
also
Acha,
has,
okay, yeah.
yes, ma'am. And
That's it.
intermolecular space is more,
Hmm.
more than solid, less than gas.
Hmm.
It can retain the shape of any container. It has
Hmm.
definite volume, but no definite shape.
Hmm. Very good. And coming to gas.
Gas, it has a definite volume, but no definite shape again.
No, gas
Uh,
doesn't have any
no, no
definite
definite
volume.
volume. No definite volume. It has no definite volume. It has more
No definite value,
intermolecular
no
space,
definite shape.
less intermolecular force between them.
Hmm. Yeah, say.
Yes, sir.
What
It
about
has no.
shape?
What about shape? It has no definite shape.
There's no definite shape. And what
Hmm.
we call the process of conversion from solid to liquid?
Solid to liquid. Liquefy. No, what was it?
Solid to liquid
Liquidify.
is melting.
Liquidation. Melting also. Yes, sir.
Melting, what even liquefaction?
Yeah. Liquidification.
Liquidification, right. Liquidification. Liquidification or liquefaction?
Hmm.
Okay, let's go with liquidification. Melting is the word, okay?
Yes, sir.
Okay. Then here we have liquid to solid. Liquid to solid is
Because freezing is used
freezing.
or
Freezing.
deliquification.
Deliquidification, solidification, but let's go with freezing. Okay. Freezing is the word. Now liquid to gas,
Yes, sir. Boiling, evaporation,
boiling, evaporation, right? And gas to liquid,
condensation.
condensation. This one, condensation. Okay. And another process is there also, which is direct solid to gas. And what do we call that?
Sublimation.
Sublimation. Now, can you tell me the difference between boiling and evaporation?
Boiling and evaporation.
Hmm.
Boiling is like when we're boiling something to their boiling point so that it can evaporate to the
Hmm.
gas gaseous state. Evaporation is like
So,
um,
evaporation is also the conversion to the gaseous state. Now,
hmm,
what is the what is the difference between boiling
uh,
and evaporation?
hmm,
Okay, let's see. Can you tell me what is evaporation? Can you tell me that a physical phenomena? What is evaporation?
evaporation when liquid reaches its boiling point and then starts vaporizing in the air, turns into gas, called evaporation.
No, just give me a physical phenomena. Like if I tell you that if I heat some water in a gas, then the water will get boiled. But when we will say that water is getting evaporated,
When the water is turning into gas.
then what is the difference with boiling?
Boiling point is like the point where the liquid starts turning into gas.
Hmm. Okay. So let's see. Evaporation and boiling. Evaporation is, let's say we have water in two buckets. We have taken water in two bowls. Now what we are doing? One, we are heating it in the gas. Okay. In the one case, we are heating it in the gas. In another case, what we have done, we have just kept it under sunlight and did nothing. So what is the boiling point of water?
100 degrees Celsius.
So when we will start boiling, what we will see here? After some time, we will see bubble is forming, right?
Hmm.
Bubble starts to form, and after some time, the whole thing started getting, like, the whole water is getting converted into bubbles, and it uh, converts into the vapor very quickly, right?
Yes, ma'am.
And if we keep some amount of water under sunlight, what do we see?
We also see vaporization after a certain
We do
time, but
we do
it's a
we see
very
any
slow
bubbles?
process. No, we don't.
We don't see any
Because we're
bubbles.
not giving it constant temperature for it to boil.
Yes, but what we see that if we keep some amount of water under sunlight, what we see that after some time the level of the water is getting reduced, right? So after some
Yes,
time,
ma'am.
what we will notice that after after some time we will see that the primarily that was our level of water, and the now we have this level of water. So the water level has reduced. Now see what is the difference when it comes to evaporation. Once we are heating it, in the case of boiling, what is the temperature? The temperature is 100 degrees centigrade.
Yes, ma'am.
But in the case of evaporation, we have just kept it under sunlight. So is the temperature of the environment is 100 degrees centigrade?
No.
It's much less than that. So what it is that evaporation, so clearly evaporation doesn't need the temperature of 100 degrees centigrade, right? Evaporation can take place even below 100 degrees centigrade. Let's say it's around 35 degrees centigrade or more, okay? At this range of temperature, evaporation starts. It doesn't have the 100 degrees centigrade. This is the first point. And second point is, as you have mentioned already, that it is a much slower process. It is a much slower process. Okay. And for boiling takes the temperature to be 100 degrees centigrade or more. So for boiling, it has to reach the boiling point. But for evaporation, it's not necessary to reach the boiling point. Okay. Next, boiling is a faster process. Okay.
Yes, ma'am.
And the final and the important point is, let's say when the sunlight is falling here, initially it is reacting with this level only. The particles, the H2 molecules of the surface level. The molecules inside are not getting reacted with the sunlight. But here, uh, movement like this is followed, and the heat is interacting throughout the water molecule, throughout the whole substance. But evaporation is having only at the surface level. So this is our last difference. Our last difference is evaporation is a surface level phenomena, and boiling takes place throughout the substance. Okay,
Yes, ma'am.
fine.
Yes, ma'am.
Okay. And apart from these, I had to say today. Okay, tell me what are the things you have read in 9th and 10th apart from the reactions? Have you read anything about thermodynamics?
Yes, ma'am.
You have read Charles and Boyle's law? Have you read the
Oh,
Charles law?
um, no, I don't
Something like
remember.
this. P where is as V, V where is as T. Anything like this?
No, no, ma'am.
No, right?
No,
Okay. And anything from thermodynamics you have read?
no, ma'am.
Okay. So let me give you another thing that we did already in the last class. Let me see what we can do. We have 4 gram of H2. We have 4 gram of H2. Then we have, let's say, 36 gram of carbon. Then we have uh, 46 gram of sodium. Okay, these are the 3 things we have. You have to tell me the again the which of these 3 has the maximum number of atoms. Okay,
Yes, ma'am.
the similar thing we have done in the last class, right?
Yes, ma'am.
So tell me which has the maximum number of atoms. Calculate and tell me.
I don't remember the molecular mass of sodium, atomic mass.
Okay, okay, okay. Last class I have told you to remember till calcium, na?
Yes, ma'am. I have to.
Number of proton is 11. Number of neutron is 12. Then what is the molecular mass?
23.
23. Okay. Now calculate.
Will hydrogen molecule have more atoms?
Hydrogen molecule have more atoms. Okay, tell me why.
Hmm. Because it has 2 moles.
It has 2 moles. What is the number of mole in the second case? In the first case, it is 2 moles. Okay. In the second case, what is the number of mole?
For second, for carbon, it has 3 moles. No,
Three
not three
moles.
moles.
Okay.
Yeah, 3 moles.
Yes, 3 moles. Yeah. And in third case,
Hmm. For third, it has 2 moles. Yes, 2 moles.
2 moles. Okay, very good. Then why it is the first one? So what is the number of molecules in the third case?
Number of molecules would be 2 into Avogadro number.
2 into Avogadro number. Number of molecules in the second case will be 3 into Avogadro number.
Avogadro number.
And the number of molecules in the first case will be 2 into Avogadro number. But as I have
Hmm.
asked you the number of atom, so in both the cases, then this will be the number of atom only, and this case the number of atom will be 4 into Avogadro.